And so I'm going to start my table by rewriting those x's and putting the probabilities of x's right next to them. I know I am going to, for the mean, I'm going to have to do x times the probability of x. And then for the variance and eventually standard deviation, I'm going to need the x squared, and then the x squared times the probability of x. So I have a lot of things I need. They're not very hard to find, but I do want to keep them straight by making a table. If I can make a straight table, that would be so cool. Okay, so starting off, I have -4, -3, -2, -1, 0, 1, 2, 3, and 4. And then I have probabilities for each of those: 0.02, 0.07, 0.10, 0.15, 0.13, 0.30, 0.18, 0.10, 0.06, 0.02. And now I'm multiplying those together. So the -4 times 0.02, so it's going to be -0.08, and so on. So I'm going to multiply -0.21, -0.2, -0.15, 0, 0.18, 0.2, still multiplying, 3 times 0.06, 0.18, and then 0.08. Now for the mean, I need to add all those up because the mean equals the sum of the x's times the probabilities of the x's. And we have that on the previous page or two. The expected value of x is the summation of the x's times the probabilities of the x's. So I've done the x's times their probabilities right here, and I just need to sum those, and that's going to be my expected value of x. So when I sum those all up, for this one, I happen to get 0. So the expected value of x, which is the same thing as the mean, is 0. When I add all those up, I get 0. So then if I square, let's continue on. If I square my x's, this one will give me a +16, a +9, a +4, a +1, 0, 1, 4, 9, and 16. And then those numbers I need to multiply by the probability again. So I have to be a little bit careful, and I'm coming over here and multiplying this column times this column and putting it in there. Okay, so probability times the x squared value. So 16 times 0.02, that's going to give me 0.32, and then I get 0.63, 0.4, 0.15, 0, 0.18, and then it's 4 times 0.1, so 0.4, 9 times 0.06, so 0.54, and 16 times 0.02 again, so 0.32. Now I want to add all those up so that I can see part of my variance formula, and I get 2.94. I'm cheating, looking what I calculated before. So 2.94. Now for this variance, I am going to do the summation of the x squareds times their probabilities, and then I have to subtract off the mean squared. So don't forget that from the formula, because it's easy to just add up that column and totally forget to take care of the other part, which is to subtract off the mean squared. I was looking for my nice formula. Yeah, on that first page there, at the bottom, those nice formulas that we came up with. So I have the, and that one's not the shortcut. Dang, why did I do that? So here is the variance formula that I'm using. Just a quick refresher there. And it's our shortcut formula, so that's the one I prefer to use. And it does subtract off the mu squared at the end. So I need to make sure I do that. So I did the sum of the x squareds times the p of x's, and that's where I got the 2.94. And then I have to subtract off the mu squared. Mu in this case is 0, so mu squared is still 0, which isn't going to change my value, but oftentimes the mean is not 0, so we would have something else. So it's 2.94 because I'll put that back in with its actual value. So when I subtract 0, nothing's going to change. So my variance is 2.94. And then if I just do, let's see, my mean and my expected value I already found, they're right here. And then my standard deviation is going to be the square root of 2.94. So since now I have that 2.94, I can just take that square root, and that's going to give me 1.72. And I'm going to be lazy and write it off to the end again so that it's still labeled when I box it. So 1.72 is my standard deviation. That's part A. So I needed to find 3 measures there, and I found them. Graph P of x. Locate mu, mu minus 2 sigma, and mu plus 2 sigma on the graph. So I want to look at, I think I need a little bit more space here. So when I go to graph the probability of x, what we're talking about is the y-axis is the probabilities of x. And so I need to go on the probabilities I see between 0.02 all the way up to 0.3. And in terms of the x values, I need to start at -4, -3, -2, -1, 0, 1, 2, 3, and finally 4. And then on the y-axis again, this will be 0.1, 0.2, and 0.3. And then for the -0.4, we had a probability of 0.02, so there's like 0.05, so it's barely above ground here. The -3 was 0.7, so that's about there. And these should be touching. -2 is going up all the way up to 0.1. Woo. -1 is going up to 0.15. 0, remember that one's all the way up to 0.3. Need my chart. One is at 0.18, so almost 0.2. 2 is at 0.1. 3 is at 0.06. And 4 is again 0.02. Now when I look at that, that looks pretty much mound-shaped. It's not exactly symmetrical, but it really has a tendency towards mound-shaped. So I'm going to call it mound-shaped. I also am supposed to find mu, which, remember, mu was our expected value, and that was the 0, so that's going to be my mu right there, so I'll just mark below it. And then I want mu plus or minus 2 sigma. So mu was 0 and minus 2 times 1.72 is going to be negative 3.44. So let's try it. 1.72 times 2, 3.44. And mu plus 2 sigma is going to be 0 plus 2 times 1.72, which will be, of course, a positive 3.44. And so at about 3.5, almost there, I'm going to put a line and call that mu plus 2 sigma, or 3.44. And then same thing in the other direction, almost to the halfway mark. And I'm going to call that mu minus 2 sigma, and that'll be negative 3.44. Now they're not always symmetrical, but since our mean is at 0, we're getting the exact same distance on either side of 0 because we're going the exact same distance on either side of our mean. So there are my 2 boundary points. And then it says, what is the probability that x will fall into the interval mu plus or minus 2 sigma? And so to know the answer to that, I need to know the shape of my data, of my probability distribution, and I'm going to call that mound-shaped. So we'll say because our probability distribution is mound, we would expect, let's look back, we would expect within 2 standard deviations, we would expect 95% of our data. We'll say 95% and in this case we're wording it a little differently. X is 95% likely to be between negative 3.44 and 3.44. So that means any x that you choose that happens to be in this data set, that 95% of the time, or that x will be between negative 3.44 and positive 3.44, or you could say for any x, it's 95% likely to be between those two marks. And that's because there are 2 standard deviations away from the mean.